Let's learn how to make this turntable effect with animating a sprite while keeping the images responsive. I use this website a lot. It is called tinkercad. Whenever I have to design something for my 3D printing, this is the site I usually launch. It's simple and it does the job for simple models, which I then export and 3D print. Let's dig around and explore how they have created this effect. If we look at the image that they've used, you'll notice that this is just a sprite with 15 poses or frames. These images are generated server-side once your model is saved. The way they animate these images is by moving the sprite left to right and vice versa. They achieve this by utilizing the background size property. If we look at the implementation, we might notice that they even resize the image with JavaScript. But for our implementation, we will be using media queries while keeping our JavaScript code dynamic. Let's start with the basics first. What is a sprite sheet? A sprite sheet is like a big image that has many smaller images inside it. These small images are called sprites. They're mostly used in video games and animations to show different characters, objects, or part of the background moving or changing. Instead of loading many separate images, a game can load just one sprite sheet, making it faster and easier to create smooth animations. Same concept is applied here with tinkercad. They load PNG images. We can see that the image is 4500 pixels by 202 pixels. In order to implement this effect in our website, we'll just yoink this image and paste it in our project. Use Emmet to build a quick starter website and add our style tags, add one div and add our script tags. We have to decide what size our image will be for large screens and small screens. We know that the original image is 4500 pixels by 202 pixels. So if we want to use a default width and height for our turntable effect, we'll have to divide 4500 with 15 since we have 15 frames. That will give us 300 for the width and our height will remain 202 pixels. In order for us to increase and decrease the size of the image, we have to keep in mind the aspect ratio of the original image. Now, how do we resize our image and keep the aspect ratio intact? Well, for large screens, let's say I want to have a width of 350 pixels. Now we have to calculate the height. For that, we'll use a formula. Original height divided by original width times the resized width. That will give us the newly resized height. In our case, that will be 202 divided by 300 times 350. That will give us the height of 235 pixels. And that is how we end up with a width of 350 pixels and a height of 235 pixels. For the small screens, I have chosen a width of 200 pixels. Applying the same formula will give us a height of 135 pixels. So this is how our image size will play with the media query. Now that we know how to calculate the width and the height, all it's left to do is to apply the correct values to the background position and calculate the background size of the image. Since we have 15 frames, it's easy to calculate the width of the background size. So for large screens, it will be 350 times 15, and for smaller screens, it will be 200 times 15. We of course add our smaller values into the media query. Now it's time for our JavaScript. First, we want to get a reference to our sprite container. Next, we want to set the total frames, which we know from the original image it is 15. Next, we want to add a mouse move event listener on the sprite container. And inside here starts the fun part. Since we have a media query, we want this to be dynamic. We'll create a frame width variable that will change based on the width of the div. Next, we want to get a percentage of where we are with our cursor in response to the div. So we calculate that with dividing the event offset with the frame width. To get a flat integer of what frame or what pose we're at, we multiply the percentage and total frames within Mathlore. And finally, to get the next position, we multiply current frames with the frame width. We need a minus in front of the current frame here. It is very important if we want to get the sheet to turn like a turntable. To make things smooth and to avoid bugs between the sizes, it's probably wise to reset the background position every time the window gets resized. And yes, this will run every pixel change, so this piece of code could definitely be improved if you are concerned about performance. And just like that, we have our desired effect working in our website. Thanks everybody for watching, and I'll see you in the next one.